Close your eyes for a moment. Picture the vastness of space. What do you see? Most of us imagine a perfect, silent emptiness, a black canvas on which stars and galaxies are painted. But what if that emptiness isn't empty at all? What if the very fabric of our reality, the stage for all existence, behaves less like a canvas and more like a liquid, an exotic, invisible ocean with zero friction? Tonight we are not just stargazing, we are diving into that ocean. We will explore the stunning theory of the superfluid vacuum, a concept that could unify physics and forever change how we see the universe. For over a century, our guide to the cosmos has been Albert Einstein. He gave us the image of spacetime as a flexible fabric, like a rubber sheet. Massive objects like stars and planets create dents in this fabric, and we feel these dents as gravity. It's a beautiful, elegant model that works perfectly on large scales. But when we zoom in, way in, down to the quantum realm, this smooth fabric tears apart. The laws of the large and the laws of the small refuse to speak the same language. This fundamental conflict has left a gaping hole in our understanding of reality, a puzzle that physicists have been trying to solve for decades. And to solve it, some are proposing we throw out the rubber sheet entirely and replace it with a quantum sea. So, what exactly is a superfluid? Imagine a liquid so perfect it has zero viscosity, absolutely no internal friction. If you were to stir it, it would spin forever, never slowing down. It can flow without losing any energy and even defy gravity, creeping up the walls of its container as if it doesn't recognize the rules of our world. This isn't science fiction. We've created these substances like supercooled helium-4 right here on Earth. Now let's turn to the vacuum of space. It's a common myth that space is nothing, but quantum field theory tells us a different, more chaotic story. The vacuum is actually a seething environment, a quantum foam where pairs of virtual particles and antiparticles constantly pop into existence and annihilate each other in fractions of a second. Emptiness, it turns out, is furiously alive. Here is where the theory takes its breathtaking leap. What if this quantum foam, this sea of virtual particles, is the superfluid? What if space-time itself is not just a geometric concept, but a real physical substance? In this view, everything we see, from an electron to a galaxy, is just a wave, a ripple, or a vortex within this vast cosmic ocean. We are not moving through space, we are disturbances in the very substance of space. This isn't just a philosophical idea, it might solve real problems. Let's start with dark matter, the mysterious something that holds galaxies together. We've been searching for a new particle for decades with no success. But in the superfluid model, we don't need one. The gravitational effects of dark matter could simply be the collective motion of the space-time fluid itself, like invisible whirlpools and currents in an ocean, guiding the stars in their orbits. And what about dark energy, the force that's pushing our universe apart at an ever-increasing speed? In the standard model, it's a mysterious energy of the vacuum, but in the superfluid model, it could be an intrinsic property of the fluid itself. As the cosmic superfluid cools and changes its state, it could generate a natural, gentle outward pressure. The expansion of the universe wouldn't be driven by a strange energy, but by the fundamental nature of space-time itself. This theory also redefines light. Instead of a particle or a wave traveling through a vacuum, light would be a wave traveling in the vacuum, a sound wave in the cosmic ether. This could explain why the speed of light is constant. It's not just a universal speed limit, it's the speed of sound for the substance of space-time itself. No disturbance can propagate through the medium faster than the medium allows. Even black holes are transformed by this idea. In Einstein's theory, a black hole is a singularity, a point of infinite density where the fabric of space-time breaks. But in the superfluid model, there is no singularity. A black hole is more like a drain in the cosmic ocean. It's a place where the space-time fluid is flowing inward faster than the speed of light, so nothing, not even a ripple, can escape. The event horizon is simply the point of no return in this cosmic waterfall. Of course, this is a theory on the frontiers of physics. It is not yet mainstream. It faces many challenges in connecting its beautiful concepts to precise mathematical predictions that can be tested. Scientists are looking for evidence, perhaps in the light from the early universe or in the behavior of gravitational waves. A ripple in spacetime from merging black holes might carry the signature of a fluid, not a fabric. The implications are profound. If this theory holds true, we are all, quite literally, fish swimming in the sea of reality. Every thought in your brain, every beat of your heart, is a complex pattern of vibrations in this quantum fluid. The universe is not a silent, empty stage. It is a single, unified, and living substance. It changes the very definition of what it means to exist. This concept, in a way, brings us full circle. Ancient philosophers spoke of an ether, a primordial substance from which everything was made. This idea was discarded with the rise of relativity. But now, through the strange lens of quantum mechanics, the idea of a universal medium is returning, reborn in a new, more powerful form. Perhaps the ancients were, in their own way, sensing a deeper truth about the nature of our world. So, we return to the quiet darkness. Is it an empty void or a silent, swirling ocean? The superfluid vacuum theory presents us with a radical and beautiful vision of the universe. One where we are not isolated travelers in a vast emptiness, but integral parts of a single, interconnected fluid medium. It's a theory still on the fringes, but it reminds us that the greatest secrets of the cosmos may be hidden not in what we see, but in the very nothing that holds it all together. Thank you for diving with us into this cosmic mystery. We are truly humbled by your curiosity. What do you believe is the true nature of space-time? Let us know your thoughts below, and until next time, keep looking up.